All right, so going through basically the same approach that we did last time, set up a new cluster, same thing, DC2 nodes, but this time I will set up 8 total nodes in that cluster. I'm going to use even a more creative cluster identifier called load test 8 and a database name of load test. Other details that you don't care about. And I did something wrong here. What did I do wrong? Oh yeah, I can't have a hyphen in here, so let me just remove that. The important difference between this demo and the previous demo being I want 8 compute nodes as opposed to 4. And I'm sure you can see where I'm going with this. So what's the wager here? Is it going to be twice as fast since I'm using twice as many nodes? Well, let's find out. Again, I'm not going to make you watch this thing provision out. If you do these demos yourself, it actually doesn't take too long, but probably longer than you want to watch. So here's my new cluster with 8 nodes. It's a brand new cluster, so I'm going to recreate that same table. We'll paste in the exact same command that we used last time, that copy command. Now, one thing I didn't mention before, that comp update off. What that does is it says don't analyze the compression in this step. We're going to save that for a future demo, and I'm doing that just so it does take a little bit longer. All right, and now jumping into the future, we saw the exact same thing, loading the exact same number of rows into the exact same table, dropped from a little over 9 minutes down to 5. So not quite twice as fast, but close, really close. All right, and now for the true contrast and comparison. I'm going to drop that line order table, recreate it really quick, and instead what I'm going to do now is I'm going to load a single file that I've prepared called line order all raw. Now this is all 600 million of those rows in one single file, and also it does not have compression. Because I've ran through these demos a couple of times already, I know that the compression cuts it right in about half. So it'll have about twice as much data to read off disk to get the same number of rows into the cluster. So I will remove that gzip clause, and let's see where this takes us. All right, so fast forwarding into the future, we can see that it took 27.5 minutes. So maybe I kind of did that in a weird order, but let's go from fastest to slowest. Going through this from one end of the spectrum to the other, 8 files compressed took right about 5 minutes. 4 files, but still compressed, took right about 9 minutes. And then the 1 file, uncompressed, so we're no longer parallel and we're not compressed, took it all the way out to 27 minutes. Now you could do the exact ratios and the exact comparison of x over y and see what that graphs out like. Really what I want to drive home, however, is following the best practices takes something that could be a roughly 30-minute process all the way down to a 5-minute process. I realize I'm doing a little bit of rounding there, but the point is the same. It saves a massive amount of time. A little over 5 times improvement.